simplify a geometric sequence. So I've already given away what type of sequence this is, right? Well, we discovered by a little deduction that you can either multiply by a half or you can divide by a value of 2 each time to figure out what these values are. Okay, so if we're going to build our geometric sequence, it's written like this: t subscript n is equal to a, okay, which is our first term, multiplied by r, which is our common ratio, and to the power of n, which is the term number, subtract 1. Okay, so all of this is kind of in brackets here. So we want to build this equation. It's pretty simple to see where the first term is. It's our 640. So we have 640. And our common ratio, okay, we don't say divided by 2. Okay, what we're looking for is that it's multiplied. We're usually looking for what are we being multiplied by, especially because this is a multiplication symbol between a and r. So we're multiplying by a half here. So our r value is the common ratio, and we can solve that by employing this idea, right? Take one term, divide it by the next, we would have ended up with our half here. So we get 1/2, and all of this is to the power of n minus 1. This in itself is acceptable as a formula, but let's say you have a teacher or you would like to simplify the formula as much as you possibly can. Okay, so this is a half, but this can also be written as a base 2. Reason being, the concept of 1/2 is equal to 2 to the power of negative 1. Okay, those two things are simple. So we could literally rewrite that right now just like that if we want. In fact, let's do it. 2 to the power of negative 1, which is to the power of n minus 1. And this here, without even writing our a term, is a power of a power. So we can already simplify by bringing this, multiplying, distributing the negative. 640. Okay. In order to simplify, it'd be nice if we could turn our first term into a base 2. But as it turns out, actually, you know, it'd be good to use that. Use a graphing calculator here. Here we go. Base 2, power of x. Whoops, that's not power. Here we go. I'm going to zoom out really, really far. We're looking for a y value of 640. Okay, so zoom way out. There we go. And it looks like it crosses at 9.3. Okay, so 2 to the power of 9.3, but that's not really going to help us in this term here for simplifying. We want to use it as a whole number integer. Okay, so what that concept means there is 2 to the power of 9 is a little bit less than 640. So jump across those pages. Take out our calculator just to make sure of that idea. 2 to the power of 9, yeah, it's a little bit less, 512. So let's split this concept up here. We can split 640, okay, into 512 times something. So the idea of 640 is equal to 512 times x. Or in our case, it's really going to be our a. So I'm going to write it as a, okay? And the reason we're doing 512 here is because we know that 2 to the power of 9 is the equivalent of 512. So we can find a new kind of a value by isolating here. So let's do our 640 divided by our 512 is equal to a. Okay? A is equal to, we'll bring out our calculator, 640 divided by 512. 1.25. So this new a, when it's not truly our a term, because the first term in this sequence is 640, but when we simplify, we're going to get as 1.25. Okay, so t at n is equal to, and what we've done, if we split this into 1.25 times 512 times all the other stuff we've already figured out to the n. I'm going to start writing this all in black to make it quicker. Okay. 512 we can change into what value? We discovered over here.
2 to the power of 9.
That's right. So this is now 2 to the power of 9. So 2 to the power of 9 times, I'm going to distribute this if you don't mind. We're going to go 2. This becomes negative n plus 1. Okay? And then we still have Tn equals 1.25. Okay? This can be simplified. The bases are the same, so we can just add the exponents. So we have Tn n 1.25 times base 2, and then we have 9 minus n plus 1. Okay, and that can be written as 1.25 10 minus n would be our simplified version of this geometric sequence.